Good day, everyone. My name is Moustafa, and I will be explaining our milestone 4. So milestone 4, we need to create a database so we can send our sensor readings to the database. So first, we'll create our database using the Django the Django database. So we will not use another data or outside database. We'll use the database that we can actually program inside Django, and then we will post it on the Heroku app. So first we need to create a new application for our database. I will name this one my API. So how do we do that? We use the Python manage.py, create our start app, and we name it my API. I've already created this one. So actually, if I go to the files, my files, and we see I already have the my API app. But first, before we start working on my API app, we need to actually add it to our original application, which is the Hello World. So first, we must go to Hello World, and we must enter the settings.py. So actually, we have to actually also make sure that debug equals false, and add our Heroku app to our allowed hosts. So the important thing here is to add our new API or our new applications, which is myapi.apps. And we also need to add the REST framework, which we will be using later on. So we'll also add it to our installed apps. And in order to use the Heroku app, we also need to add one more thing, which is activation of the Django Heroku. So this line, we needed to activate our Django Heroku debugging. So now we have created all this. We need to actually create our model, and we also need to activate our database. So Django already comes with databases, but we need to activate these databases. These databases are the permissions, passwords, the super users. So these databases are already built into the Django, but we need to activate them. So how can we do that? We need to run the Python 3 manage.py migrate. So by this way, we can actually, so we have already migrated the admin and the authentications, content types, and I've already created our model, but I will explain it now. So these are all the databases that are inside our application or inside our web servers right now. So we actually activate them by using the manage.py migrate. So now we need to create a model. We will go to the My API application, and we need to create a model. So we will go to nano models.py. We need to create the model for our database. So we will name our database sensor, and we will so first we need to add from the Django database. We need to import our models. So we have here three characters or three inputs that we have. Is the temperature, our IC, which is the one that we get from our RFID sensor, and the distance which we get from our distance sensor. So after we have, so this is our class or the class for our database. So after we finish this one, we need to actually add or commit these changes to our database. How can we do that? By using the Python 3 manage.py migration. But because we actually need to update, we will also make migrations. So by this, we will actually update our models or update our database. So we have created our model, but we need to serialize it. Serialization means translate our objects from models into a format that we can store it into, like the JSON format. So how can we serialize? So we will create a serializer.py. We will create our serializer file in which we will import the REST framework, which is the main system that we will be using in the Django. So this is the main library. So from REST framework, we need to import serializers. We have already installed the REST framework. After we finish, I will show how to actually install it. And from the .models or the model file, we need to import our model, which is the sensor. So this is our serializer function. So we will name our function sensor serializer, and we include model for sensor. So here is the fields that we will actually serialize or turn into JSON strings: our temperature, our IC, our distance, and also here I've added an ID. ID isn't actually a variable that we send to our system. It's more like a count or an integer. So this is like the input of every message that we send. It will automatically count, give a count to every message. So now we have serialized our models. So we need to actually insert our serializer into our views page. So how can we do that? We go to views. So we go to nano views.py. We need to add our serialized content here. So from REST framework, we import view sets. View sets is a way that our query database handle the post and get requests. So now we have our serializer. We need our serialized database. We need to enable it into the views so we can actually send and get requests, send and post, get post requests to our database. So from serializer, we import our function sensor serializer, and from models, we import our model sensor. This is the function for the query set, or so first we actually identify our query set by distance, and we identify our class as sensor serializer. So this is basically a way to view our database so that we can actually get, so we can actually send, get, or post requests through URL. So actually, after we have done this, we have one final step, which is adding our you can call it URL or path for our page. So we will go to our original Hello World application, cd Hello World, and we will go to your nano URLs.py. So we need to actually assign a path to our new application, which is my API. So here from URL patterns, we will add a path. We will leave this one empty, so it's just like it will be our home page, and include my API.urls. But also, since we actually need to actually put it also in our my API, so this will actually need to go both ways, so that my API can actually update the database whenever we have a new request. We'll go to cd my API, and we'll go to nano urls.py, and we will add our new path, which is empty. Also, we need to add our library function called routers. Routers is a function that allows us to update the database every time there is a request, a get or post request is made. So the router function is basically to connect our database with our URL. So here we have identified URL path, it's empty, and we also make one more, which is the API authentication. The REST framework actually comes with a built-in authentication protocol, so we can actually log in and edit our database from the API dash authenticate path. So now all of this is done, and we need to actually import we need to actually post our application to our Django database, to our Heroku application. So how can we do that? We actually explained this one before, but we can re-explain it again. So how can we do that? So I've already explained that we need to debug equals false and activate Django Heroku in the settings of UI. One more thing is the Heroku login. interactive, because we are using so we can actually, we are already logged in, so we don't need to log in. And we can also Heroku create, and we will name our application SKEL4213. I've already posted this. So like this, we have actually connected our web server file to the application on Heroku. So after we are done with this, we actually need to git push Heroku, and we have actually named my branch in the GitHub web server. So this is basically how we can push the details or our files from the GitHub to our Heroku app. And this is all for the Django part in our application or in our web server. Next, I will discuss how we create the dashboard. So this is our default database in which is uploaded to the Heroku app. So I have already sent some data to our database, and as we can see here, it's identified or sorted by the distance as we mentioned in the serializers file. So it goes from lower to higher distance, so distance 0.5, 1.6, 1.9, so on. And we also have our ID or our count. So this is the first sent reading, second, third, fourth, and so on. So how do we actually send this? How do we actually send our sensor readings? I've already explained this in our milestone 3. We use IoTify to send our sensor readings. So now I have to actually, we will explain our dashboard. So this is our app in Heroku. There are two ways we can actually create a dashboard. I have used this one application. It's a free application in my Heroku app, which can create our dashboard for us by using the database that we already uploaded to our Django server. We can actually use also, I use Trevor for my dashboard. There is actually another dashboard called Draxler, but I use this one because it's better and easier to use. So here I have accessed my Cloud 4213 web server database and my dashboard. So now it's loading our dashboard. So first, we need to actually build our charts or the tables that we want to do. So I will view here some tables that I've already created. So this is our basic table. It has all of the information that's already listed on our database, but in a more, but it looks more like a table or a dashboard table. The best thing about Trevor is I can actually see the history, how I created my query or how I created my table. So first, I added all the information from my API sensor, and I reordered my table by ID, IC, then distance, then temperature. And I sorted my table with the IC from descending to ascending order. And that was all for my first table, which is basically a view of all our readings. Now we will go to a more precise chart. So this is my temperature chart. So first, I input all of the readings from my API sensor. I also sorted the readings by distance from lowest to highest. So as you can see, from 0.5 till 2.25. Then I summarized my table from only temperature and distance. So here we actually need to make a bit of change before we can use our table to create any charts or biometrics. We need to actually convert our details or our database from strings to array. So this is what I actually did. So we can actually see here command. I actually first changed my temperature readings to array, and I changed my distance to array, and then we are left with distance and array temperature. So we can use our pie chart, or we can actually use bar chart or line chart. I actually used line chart for this one. So basically our y-axis is the one, the array or the temperature. So I actually, for this query, I actually only converted the array temperature. So I actually only converted the JSON strings in temperature to array. So we can display it in a sort of or sort of integers here, numbers. So it will actually be converted into numbers, and distance remains the same because actually here in this chart, the temperature changes is the only thing that matters here. And distance, we don't need to actually view it in a dynamic matter. We can stay as a variable as it is right now. And our last chart is the one for the accuracy table, and the one that actually needed all the work. So first, as you can see from my history, the number one step is I imported all of the sensor readings. Then I summarized into temperature, distance, and that's all of the actually variables that I need from my table. So I copied the temperature here into two tables. So maximum temperature from and the average temperature. So here I copied one column, and also I changed all of these variables into arrays, so I can calculate so here you can see I actually changed them all to float, so I can actually calculate here average temperature. So use the summarize function to calculate the average temperature, and here summarize function to calculate the maximum temperature. Also here the average distance. So we can see here from step number 9. So step number 9, all of the calculations that I made. So average for average temperature, maximum, average distance, and also count. So here from the ID, I actually summarized it to count by number of readings. So this is actually, as you can see here in my first step, I have left my sensor ID. So the ID number, as I mentioned before, so we can actually perform count. So for every temperature reading, there is a count. So the total count is 6. And one final thing is, one final tab is the accuracy tab. This is actually a new column. So I did it by the add column function. As you can see here, I can actually add from the columns, I can add a new column. And after I say add new column, I actually need to enter the formula. So I made this formula average temperature times maximum temperature. And so it can be in percentage. I did one more thing, which is the mathematical function times n, and I multiplied my accuracy by 100, so it can be in, as you can see here, 9.4.998. So it can be in percentage function. So that's all for this accuracy table, and then I reordered them now into number of readings, average temperature, maximum temperature, average distance, and accuracy. So these are the 3 tables I will be using for my dashboard. And we can see here, I can actually see my dashboard, the one I created right now. So this is how I choose to view my dashboard. So I have the table, I have temperature chart, and I have my accuracy table. And I turn the pin into public, and we can actually use this one, share. So I can actually share only the dashboard link, and there's a pin code that I can share to specific individuals if I want, or I can share a link that already has the pin code pre-filled. So here we will try it out So we will see our temperature now, our dashboard now. So it actually takes a little more time. So until it's done, yeah, see, as you can see here, this is my dashboard, or this is the user view of a dashboard. The user can actually sift through the table. So if there's any more readings, the user won't have any problem sifting through the readings for the table. And here, if I've already actually made the graph easier to see by adding these numbers, the temperature reading numbers above every bar. But actually, if it's hidden, if the temperature reading is hidden, which is an option, the user can just move the cursor to point at the bar he chooses, and you can actually see here the temperature reading. Also, the accuracy table here is already, as you can see, it's just a simple table. So now we actually need to test our dashboard. So let's say our user is actually going to send a new item. So I will simulate a new send or a new post request. So I will write here test dashboard. So here I'm using the IoTify to actually post the number of sends one, repeat message only one, and let's start our simulation. So as you can see here, our simulation ID, our simulation here is finished and success. One sensor reading has been sent. So now we can actually update our database and see if the changes were included. So here we're going to refresh our tab to see if our database has actually been updated. So actually, best thing about Trevor is we can control how many times the database is updated. So for here, we can actually make it an hourly update or a daily update at a specific time. Or we can choose to update it right now if we want. So let's see how it looks like right now after 7 readings. So you can actually see here number of readings equals 7. Accuracy already has changed. It was 94.9 before, now it's 95.02. Our average temperature and our maximum temperature has changed. And now since we have a lot of readings, let's see how our table view has changed. So as you can see, it's actually a pretty good design for our table. You can go right or left, or you can choose to show all and you can scroll through it. And as you can see here, our temperature chart is can still actually we can still actually view it or view the whole graph or bar chart. So this is our dashboard and our database for milestone 4. The next step would be to document all of my code in the GitHub so it can be easily read and used. And also I will share this dashboard with my friends and see if any recommended changes. Thank you for listening and have a nice day.